Alright, so in this problem, I have 9 to the power of m minus 9 to the power of n is equal to 648. So based on first glance, we can tell that m is greater than n because the result is a positive number and the bases are the same. So 9 to the power of m minus 9 to the power of n, this is a positive number, meaning 9 to the power of m is greater than 9 to the power of n, and m is greater than n. So now that we know this, we can say that m is equal to n plus some number k. And now I'm going to replace m with n plus k. So now I have 9 to the power of n plus k minus 9 to the power of n is equal to 648. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of n plus k, that's going to equal 9 to the power of n times 9 to the power of k. Now I have this minus 9 to the power of n is equal to 648. Now, if I factor out 9 to the power of n, I get 9 to the power of n times 9 to the power of k minus 1 is equal to 648. And 648 I can rewrite as 81 times 8. So now I have 9 to the power of n times 9 to the power of k minus 1 is equal to 81 times 8. Now, 9 to the power of any number, that's going to be odd, right? 9 to the power of any number is odd. And 9 to the power of any number is odd, but an odd number minus 1 is going to be an even number. So 9 to the power of n is odd, and 9 to the power of k minus 1, that's going to be even. So 81 is odd, and 8 is even. And notice how we have something in the form a number times another number is equal to another number times another number. And it's an odd number times an even number is equal to an odd number times an even number. Meaning we can set the odd numbers equal to each other and the even numbers equal to each other. So now I have 9 to the power of n is equal to 81, and I have 9 to the power of k minus 1 is equal to 8. So for 9 to the power of n equals 81, n is obviously equal to 2 because 9 to the power of 2 is equal to 81. And for 9 to the power of k minus 1 is equal to 8, this is a simple equation. I'm going to first start by adding 1 on both sides, so I have 9 to the power of k is equal to 9. And 9 to the power of what is equal to itself? 1. So k is equal to 1. Now remember how we set m equal to n plus k, meaning m is equal to n, which is 2, plus k, which is 1, so m is equal to 3. So n is equal to 2, and m is equal to 3. These are my solutions for this equation. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now, if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I've logged 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 3 is equal to 130. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 4 to the power of x plus 3, that's going to equal 4 to the power of x times 4 to the power of 3, which is equal to 130. Now I'm going to factor out 4 to the power of x, so I get 4 to the power of x times 1 plus 4 to the power of 3 is equal to 130. Now 4 to the power of 3, this is equal to 4 times 4 times 4, which is equal to 4 times 4 is 16, and 16 times 4 is 64. So now I have 4 to the power of x times 1 plus 64 is equal to 130. Now 1 plus 64 is 65, so I have 4 to the power of x times 65 is equal to 130. Now we obviously want to isolate x here, so I'm going to go ahead and divide both sides by 65. So then these two cancel out, and I'll be left with 4 to the power of x is equal to 130 divided by 65, which is 2. Now to solve this, we can obviously tell that x is going to be less than 1, because if you plug in x for 1, you get 4, just 4 regular. So I'm going to first start by rewriting 4 as 2 squared. And now I have 2 to the power of 2x is equal to 2, meaning 2x equals 1 and x is equal to 1/2.